All right, good morning, guys. Welcome to our second digital Buc-ee's challenge. I'm so happy you guys had a good time doing the first one. So I'm going to start by reviewing the final questions I left you with. So here they are. For the first problem, many teammates said that Diego won because a tenth will go farther than a hundredth when comparing. So people said 5 and 10 hundredths or 5 and 1/10 is greater than 5 and 1/100th. I agree with you. Diego did won. He did throw the frisbee further. For the second problem, teammates said Tyler swam the length the fastest because 15 hundredths of a second is less than 30 hundredths of a second when comparing them. So 35 and 15 hundredths of a second is less than 35 and 30 hundredths of a second. I also agree with you. So you guys definitely understand that when the number is smaller, that means the person is faster. Okay, so let's continue on with today's lesson. We're going to start with our warm-up. And our warm-up, like I always do in class, is which one doesn't belong. There are 4 numbers. I would like you to pause this and take 5 minutes to argue which number doesn't belong. Remember, it's possible that you could argue more than one number. As long as you have a mathematical argument, that's all I care about. All right, so here are some thoughts that I had about which number doesn't belong out of that list. I said 4 and 381 thousandths does not belong because it has 4 digits. It is also the only number to have a digit in the thousandths place. 4 and 4/10ths does not belong because it is the only number that has both a 4 in the ones and tenths place. It is the only number to have a value in the ones and tenths place that is the same. 4 and 38 hundredths does not belong because it is the only number to have a digit in the hundredths place. In this case, the 8 is in the hundredths place. 4 and 0/10ths does not belong because it is the only number that is just 4 wholes. It does not have a decimal or fractional part that is less than 1. You could also argue, which is something we're going to get at today, they all belong because all the numbers are closest to 4 wholes rather than 5 wholes. And that's what we're going to begin to talk about. What does it mean if a number is closest to a specific whole, even though it has a decimal part that goes with it? So here's today's Buc-ee's challenge. It's called a bag of candy. So as you can see, I put a picture of a large bag of candy, probably something you might see around Halloween. Okay, and we're going to talk about that. So it says, large bags of candy sell in bags weighing 2 and 915 thousandths kilograms. How much candy is this when rounded to the nearest tenth? How much candy is this when rounded to the nearest hundredth? How much candy is this when rounded to the nearest 1? Justify or explain or defend your answer using place value. So here's what I'm going to do. I'm going to pause the video. I want you to do the same thing. And I want you to take 5 minutes and write down anything you notice and wonder about the big problem. So again, here's the big problem. I want you to take 5 minutes and write down anything that you notice or wonder about the big problem. All right, what did I notice and what do we wonder when we talk about this problem? So here are some notices that I had. We are rounding the same number to different place values. So we want to think about what that might mean. The place values we are rounding to might involve decimals. We are rounding to the nearest tenth. We are rounding to the nearest hundredth. We are rounding to the nearest whole. What are some things I wonder? Why do we round numbers? How does it change the way the numbers look after you round them? Will we get the same answer if we round to different place values? How do we round numbers involving decimals? Is it the same way as we round whole numbers? What place value do you round to when it says round to the nearest whole? It wonders. A whole is not a place value. So again, here is Bucky's challenge. We have a large bag of candy. You need to take this number, 2 and 915 thousandths kilograms, and round it to the nearest tenth, round it to the nearest hundredth, and round it to the nearest one whole. Make sure you're justifying your answer. Now would be a great time to pause the video and take 5 to 10 minutes to try and figure this out. Please make sure you use any strategy that you know, but make sure you're justifying your answer using place value. Let's go over the Bucky's challenge problem. We're going to start by rounding 2 and 915 thousandth kilograms to the nearest tenths place. So if you look, I made a place value chart here that has the ones, tenths, hundredths, and thousandths, and I put each digit where it belonged. So I have the 2 in the ones place, the 9 in the tenths place, the 1 in the hundredths place, the 5 in the thousandths place. So the first thing I need to ask myself is what 2 tenths is 2 and 9 tenths between? Because when we round to the nearest tenth, we're talking about the tenths place. The number is no longer going to have a digit in the hundredths and the thousandths place because we just want the number to end with a tenth. So what I did was I started to count out by tenths, starting at 2 wholes. So I have 2 and 1 tenth, 2 and 2 tenths, 2 and 3 tenths, 2 and 4 tenths, 2 and 5 tenths, 2 and 6 tenths, 2 and 7 tenths, 2 and 8 tenths, 2 and 9 tenths. Then it got tricky. I had to think about what was the next tenth. So I realized it was 3 wholes because once I get to 9, I have to move up to the next place value. So the 2 tenths that 2.9 are between are 2.9. Oops. And 3.0, or 3 wholes, okay? 3 and 0 tenths. So now, in order to round like you've done before with whole numbers, you always want to look to the place value next to it. In this case, the hundredths place. Because that hundredth is going to tell me, is that hundredth making my number closest to 2 and 9 tenths or 3 and 0 tenths? So there's a 1 in the hundredths place. So this is what I did. I made 10 little markings in between 2 and 9 tenths and 3 and 0 tenths to represent the hundredths. Okay, so here are my little markings. But that's really hard to see when I'm counting by hundredths. So I decided to zoom in on this spot right here. Zooming in on this spot right here, and I created a number line now that included the hundredths, because based on where the 2 and 91 hundredths is, I can decide if this is closer to 2 and 9 tenths or 3 wholes. So I started to count now by hundredths. So if I was to write this, this would really be 2 and 90 hundredths. So I have 2 and 90 hundredths, 2 and 91 hundredths, 2 and 92 hundredths, 2 and 93 hundredths, 2 and 94 hundredths, 2 and 95 hundredths, 2 and 96 hundredths, 2 and 97 hundredths, 2 and 98 hundredths, 2 and 99 hundredths, and 3 and 0 hundredths, okay? So look, here's where I'm at 2 and 91 hundredths. So when I look at my number line, I can easily see that 2 and 91 hundredths is closer to 2 and 9 tenths. So in this case, because of the 1 in the hundredths place, this number is going to round down instead of rounding up to the nearest tenth. So this number, 2 and 915 thousandths kilograms, if I'm rounding to the nearest tenth, is going to round to 2 9/10. And that's because of the 1 in the hundredths place. The 1 in the hundredths place makes this number closer to 2 90/100ths or 2 9/10 versus 3 0/10. All right, so now I'm looking at 2 915 kilograms from the perspective of the hundredths place, because we want to round this number to the nearest hundredths place. So again, I put the digits in the correct place value spot, the 2 in the ones, the 9 in the tenths, the 1 in the hundredths place, and the 5 in the thousandths place. So again, I was asking myself, what 2 hundredths is 2 915 between? So again, I'm looking at the hundredths place. I see there's a 1, so I decided to start counting by hundredths. So I have 2 91/100ths, 2 92/100ths, 2 93/100ths, 2 94/100ths, 2 95/100ths, 2 96/100ths, 2 97/100ths, 2 98/100ths, 2 99/100ths, 3 0/100ths. So if I look at this number, 2 91/100ths is between 2 91/100ths and 2 92/100ths, because there's a 1 here in the hundredths place. So the next hundredth is 2 hundredths. So now, like we did before, when I'm rounding to the nearest place value, I'm looking at the digit that is next to it, which in this case is the 5 in the thousandths place. So we're thinking to ourselves, what does the 5 in the thousandths place do? Is it going to move this number up to 2 92/100ths, or is it going to move it down to 2 91/100ths? So to do that, I decided to mark out the thousandths in between 2 91/100ths and 2 92/100ths. So here they are. I marked them out, but they're really tiny. They're really tiny, so they're hard to see. So again, what I decided to do was I was going to zoom in on the thousandths that exist between 2 91/100ths and 2 92/100ths. So here I made a number line counting by thousands. So look, here I start. 2 910 thousandths, 2 911 thousandths, 2 912 thousandths, 2 913 thousandths, 2 914 thousandths, 2 915 thousandths, 2 916 thousandths, 2 917 thousandths, 2 918 thousandths, 2 919 thousandths. And then again, once I get to the 9, I get to move up a place value. So now I'm at 2 920 thousandths. So this is where my number is. If I look at it, the digit in the thousandths place. There's a 5 in the thousandths place. So I have to ask myself, is this 5 in the thousandths place going to bump the number up to 2 92/100ths or bump the number down to 2 91/100ths? The trick here is when we're at 5, that's kind of the midway point, it's always going to move my number up. And you used to say this to me all the time. If it's 5 or higher, it goes up. If it's 4 or lower, it goes down, which is true. So in this case, here, this number is going to round up to 2 92/100ths. So when I'm talking about rounding to the nearest hundredths place, the number next door is forcing me to move up because it is a 5. So 2 915 thousandths rounded to the nearest hundredth goes to 2 92/100ths. Remember, if we're rounding in the hundredths place, that has to be the last digit of the number. The thousandths disappears because we are just talking about rounding to the nearest hundredth. All right, now finally, we're trying to round 2 915 thousandths kilograms of candy to the nearest 1. What does 1 mean? 1 is tricky. 1 is symbolizing the ones place. It is also talking about the nearest whole number. When they're asking you to round to the nearest whole number or the nearest 1, they're talking about the ones place. And that's tricky because the other ones mention the place value in the name. And this one doesn't always mention the place value right in the name. So I need to think, what two whole numbers is this number between? And this is where it's tricky. We know the whole in this number is 2. So then what's the next whole that comes after it? Well, 3. And again, because I'm talking about the nearest whole, or talking about the number in the ones place, I have to look next door to the number in the tenths place, the digit in the tenths place, to determine whether this number is going to be closer to 3 wholes or closer to 2 wholes. So these are my 2 wholes that it's between, 2 and 3. So I decided to count out by tenths because that's the place value that's going to determine whether this number rounds up or down. So I have 2 wholes, 2 and 1/10, 2 and 2/10, 2 and 3/10, 2 and 4/10, 2 and 5/10, 2 and 6/10, 2 and 7/10, 2 and 8/10, 2 and 9/10, and 3 wholes. And look, 2 and 9/10 is where this number is if I just look at the digit in the ones and the tenths place. Well, in this case, it's pretty obvious. If I'm looking at 2 and 9/10, you could see, based on where it is on the number line, that is much closer to 3 wholes than to 2 wholes. So 2.9 rounded to the nearest whole kilogram is 3 kilograms. And I want to talk to you about this in a second. When you buy candy or you go to the grocery store and you're weighing something on a scale, it's very common that you round something to the nearest whole. You're not really going to always weigh something or measure something all the way out to the thousandths place. You could if you want to be very exact, but it's much more common to round to the nearest tenth or to the nearest whole or to the nearest one, as we say it. So 2 and 915 thousandths kilograms rounds to 3 wholes. Here are my reflections from today's lesson. Rounding numbers is a way to make numbers easier to work with so we can do mental math. Rounding is also a way to see how we can round to a specific place value, like a whole number, a tenth or a hundredth, and what number it is closest to. Sometimes it makes more sense to round to a specific place value depending on the situation. Like the example I gave about going to the grocery store. You often want to round to the nearest whole, like the nearest whole pound or the nearest whole kilogram. The way we round decimals is the same way we round whole numbers. So if it's 5 or higher, we're rounding up. If it's less than 4 or less, we are rounding down. So here's what I want you to do. Here's a follow-up problem. I want you to go ahead and take these 4 numbers and round to the nearest whole number, the nearest tenth, and the nearest hundredth. I would pause it right now and do this. Questions. If you have any questions about anything I discussed or have answers to the problems I left you to solve, please email me your responses or send me a message on Dojo. I will start Tuesday's video with the answers to those questions, and I love hearing from you via email. I hope you have a wonderful weekend, and I look forward to chatting with you guys on Tuesday or before. Bye! Oh yes, guys, Bucky says hi. He's having a little bit of an attitude this morning because I'm not playing with him as I'm recording the video. But he loves you all. Talk to you soon. Bye.